welcome back. It's great to have you here today. In this video, we are going to talk about the factor theorem. We will go through the theorem first, and then we will do some examples together. So please get your pen and paper ready and work through these questions with me. So let's first look at fx is x subtract 2, x plus 3. Now x subtract 2 is factor 1, x plus 3 is factor 2. Let's try f2. f2 equals 2 subtract 2 multiplied by 2 plus 3, which is 0 times 5, and that is 0. If we try negative 3 subtract 2 multiplied by negative 3 plus 3, and that is negative 5 times by 0, which is 0. Let's think about this one. If fx is x subtract 2, x plus 3, x subtract 7, x plus 8. Now have a think. What is f7 and what is f negative 8? So f7 will give us 0 because 7 subtract 7 is 0. F negative 8 will also give us 0 because negative 8 plus 8 is 0. If I multiply this function by x subtract a, x plus b, we can see that fa is going to be 0 because a subtract a is going to be 0 when we substitute a into the function. F negative b is going to be 0 as well because negative b plus b will be 0. And we don't care what we have in the other brackets. It's because 0 multiplied by anything is going to be 0. So we can conclude that if x subtract a is a factor of fx, then fa is going to be 0. And the other way is also true. If fa is 0, then x subtract a is a factor of fx. Let's have a look at a few questions. First question, we needed to show that x subtract 2 is a factor of x squared plus x subtract 6. Now what we can do is to factorize this quadratic, and we will see that x subtract 2 is a factor. If we are going to use factor theorem, we can substitute 2 into this equation, and we will see that 4 plus 2 subtract 6 will give us 0. Therefore, by factor theorem, x subtract 2 is a factor of x squared plus x subtract 6. Now, you might be thinking, why do we have to use factor theorem if we can factorize this quadratic equation? Have a look at the second question. Now, in this question, I would like to show that x subtract 2 is a factor of this cubic equation. Now, hopefully, if we can factorize this cubic equation, then we will be able to show that it is a factor. However, this is going to be a more difficult case. Therefore, if we have a factor theorem, we can simply substitute 2 into this cubic equation and show that it's going to be a 0. Therefore, by factor theorem, x subtract 2 is a factor of this cubic. Okay, so now moving on to the next question. In this question, I would like to sketch the graph of this quadratic equation. Now, when we want to sketch a graph, we need to make sure we label its x and y intercepts. So in this question, we can factorize to find its x-intercept. And y-intercepts we can tell from the equation negative 6. We will be able to see that this is the graph of this quadratic equation. Okay, so in this question, we wanted to sketch the graph of this cubic equation. So these three numbers multiplied together should give us 30. And if we can find these three numbers, we'll be able to find its x-intercept. So as we can see in the previous example, if we find a value so that the y value is 0, then it's our x-intercept. 2 is an x-intercept, and negative 3 is also an intercept. What we can do here is to try fx. If we try 1, as we can see, that is not going to be 0. Therefore, that is not a factor we are looking for. If we try negative 1 cubed subtracted 10 times by negative 1 plus 19 times by negative 1 plus 30, and that is 0. By factor theorem, x plus 1 is a factor of this cubic equation. So we have found the first factor. What we needed to do is to find the rest of them. By using Farmer's field, we can see the first term is x cubed. We have to multiply x squared to get x cubed. Therefore, this is going to be x squared. We need negative 10x squared. That means this should be negative 11x squared. So we'll be able to find that this term is negative 11. Now we have 19x in the equation. Therefore, this should be 30x. That gives us the final constant is 30. That is the same as the equation given in the question. Therefore, we have factorized this cubic equation into to x plus 1, x squared subtract 11x plus 30. Now what we need to do is to factorize this quadratic equation by using Farmer's field. And as we can see, this is x subtract 5, x subtract 6. Now we will be able to sketch the graph with the x-intercept negative 1, 5, 6, and its y-intercept of 30. Okay, now let's look at the final question, question 5. Given that x plus 2, x subtract 3 are factors of this cubic equation with the coefficient of x cubed and x squared unknown, we want to find the values of a and b. There are two different methods. Method 1, because x plus 2 is a factor, therefore by factor theorem, we know f negative 2 is going to be 0. If we substitute negative 2 into that cubic equation, we will have negative 8a plus 4b plus 28 plus 24 is 0. By rearranging, we will have negative 8a plus 4b is negative 52. Similarly, x subtract 3 is a factor. By factor theorem, f3 should be 0. We will get the equation 27a plus 9b subtract 42 plus 24 is 0. Simplify this equation, we get 27a plus 9b is 18. Now we need to solve this simultaneous equation, and we'll be able to find that a is 3, b is negative 7. Okay, now let's look at the second method. Because we know x plus 2, x subtract 3 is a factor, we know that we need to find the final factor, so that we'll be able to get ax cubed plus bx squared subtract 14x plus 24 after we expanded the bracket. Now let's use the Farmer's field. We know this is one of the factor. We know that the constant term is 24. Therefore, negative 4 times negative 6 will give us 24. Multiply negative 4 with negative x will give us 4x. Now in the question we have negative 14x. Therefore, we should have negative 18x here. So we can work out this term to be 3x. Now by completing this Farmer's field, we will be able to find b is negative 7 and a is 3. As you can see, two different methods will give us the same answer. Okay, that is it for today. Well done for making through to the end, especially if you have done the questions yourself. Remember, maths isn't a spectator sport, and we have to keep practicing to be more fluent. Happy revising, and I'll see you in the next video.